Hi, I'm Mary, and this is another magical math moment. This video is designed for our Algebra 2 students who are learning about logs for the first time. Pre-cal students might find this a nice refresher as well if they haven't thought about logs. So here we go, let's get to it. We're going to be talking about expanding and condensing log expressions in this video. So we're going to start just with a little refresher of the properties of exponents. Think back to dealing with exponents and simplifying expressions. So I have x squared times x to the third. We know to keep the base and add the powers or exponents. So this is x to the fifth. When I'm dividing two expressions with the same base, I keep the base and subtract the exponents. 5 minus 2 is 3. And finally, if I'm raising a power to a power, I keep the base and multiply the exponents. Okay, so x to the sixth. Now the important thing for you to remember is that a log is an exponent. So if I'm dealing with log expressions, the laws and properties of exponents also apply to them. Let's look at log base b of m times n. Excuse me. Since we are multiplying, we're going to be adding these two factors. So this is going to be expanded as log base b of m plus log base b of n. A log is an exponent. When we're multiplying logs, we are adding the exponents. So we're just adding them. That's all we're doing. Similarly with division, I'm going to subtract. So I've got log base b of m minus log base b of n. Finally, when I'm raising a power to a power, I multiply the two exponents. Now with this, I've got log base b of m raised to the n power. What I'm going to do here is essentially kind of bring that n down in front. So this is n times log base b of m. Okay. If you are expanding, you're going from something that's small to something larger. You can also go the other way with this. So if you see two logs being added, you can put them together with multiplying. If they're being subtracted, you can put them together with division. If they're being multiplied, you can bring that exponent or the coefficient up in front as an x. Let me say that again. You can bring the coefficient up front, up to the top as an exponent. Okay, so you can go back and forth either way with this. An important thing to remember, you cannot have a negative base when using logs. Okay, so let's try them. When we are expanding, we can't have a radical or any exponents in our final answer. Terms that are on top of a fraction in the numerator are positive. Terms that we get from the bottom are going to be negative. So our first one is log base 3 of 9 times x squared divided by 7. So we have log base 3 of 9. It's on top, the term is positive. The next factor I have up here is going to create my second term, also positive because this factor is on top. Log base 3 of x squared. 7 is on the bottom, so the next term will be negative, log base 3 of 7. Once you've split it up, now you can go ahead and simplify where you can. Log base 3 of 9 is 2. Log base 3 of x squared, I want to take that squared and bring it down front. This becomes 2 times log base 3 of x. And then this would just give me an ugly decimal. I'm going to leave that alone. Minus log base 3 of 7. And that's that. All right, let's try another one. We've got log base 4 of 4 times the square root of y. Okay, so I'm going to first split this up into log base 4 of 4. This is times that, so we're going to split it with addition. Log base 4 of the square root of y. Now remember that we can't have this as a radical, so I'm going to rewrite that as y to the 1/2 power. Log base 4 of 4 is 1. The 1/2 power has to come in front. 1/2 log base 4 of y. And there we go. We can also go the other way where we have things spread out and we can condense it to the smallest thing that we can. So when we're condensing, we can't have any rational exponents in our answer, so we'd have to convert those to radicals. Positive terms in our expression are going to go up to the numerator on top. Negative terms will go to the bottom in the denominator. I have 3 log x minus 7 log y plus 2 plus 1/2 log z. Now remember, if they don't give you a base with log, it's assumed 10. So if it helps you to kind of fill that in, and then we have to think about this a little bit. So log base 10 of something is 2. So 10 to the second is 100. So our missing term here is really log 100. Let's go ahead now and try to condense this stuff. I have a negative, so I know that when I'm doing this, I am going to have a fraction in my answer. The 3 is going to go up to be the exponent of x, so we're going to have an x to the third on top. Negative 7 log y, the 7 goes up as the exponent, negative sends the term down. Y to the 7th is on the bottom of the fraction. 2 is the same thing as log 100. Since this is being added, it's a positive term. I'm going to keep this 100 on the top. And then finally, this 1/2 is going to go up as the exponent with the z. Positive means it's up in the top as well. Z to the 1/2. Okay, unfortunately we have a rational exponent and we have a constant in the middle. It's kind of weird. So I'm just gonna go ahead and rearrange some things here. I'm gonna put the 100 out in front. I have an x cubed, and then I have z to the 1/2, which is the same as the square root of z. I have y to the 7th on the bottom. And that's all we can do. Okay. Let's try another one. Negative log base 3 of 7 plus 2/3 log base 3 of x minus 5 log base 3 of y. So I have negatives. I know I'm going to have a fraction. Negative means the 7 is going down to the bottom of the fraction. 2/3 is going to come up as the exponent. Positive term means this is up on the top, x to the 2/3. Minus means this term will go down to the bottom. 5 comes up as the exponent, y to the 5th. I can't have a rational exponent, so we're going to go ahead and make this the cube root of x squared over 7y to the 5th. And that's that. Now, if you end up with a situation where you would have a radical on the bottom, that's fine. I know the temptation is to rationalize and everything else, but we don't need to get that intricate with logs, okay? So that's how you deal with logs. Maybe you're thinking, wait a minute, Mary, what about natural log? I'm glad you asked. Let's check this out. All right, we have to expand the ln of 3e over x to the 4th. Remember with ln, the base is e, so kind of keep that in mind as we go. So I've got ln 3, the 3 is on top, so it'll be positive. Next, I'm going to have plus ln e, because again, the e is on top, the term is positive. X to the 4th is on the bottom, the term is negative, ln x to the 4th. Once you've got it split, see if there's anything else you need to do. ln 3, that's a decimal, leave it alone. Ooh, ln is 1. How do you like that? 4 is an exponent and it needs to come down in front. Minus 4 ln x. That's it. The order doesn't matter. Some people don't like this 1 in the middle. There's really no standard form when it comes to these logs. It's not a big deal. Okay. All right. Last one. ln 6 minus 2 ln x plus 1/2 ln y. We're going to condense this into one expression. I know that these numbers out front, my coefficients are going to go up as exponents. So I've got a negative. I know I'm going to have a fraction. Positive ln 6 stays up. Minus 2 ln x, negative, this term is going to move down, x squared. Positive, this term will go to the top as a factor. 1/2 goes up, so y to the 1/2 is on top. I can't have rational exponents when I'm condensing, so I'm just going to rewrite it as 6 times the square root of y, because y to the 1/2 is the square root of y, over x squared, and we're done. You may be thinking, do I need to write all of the steps? No, you don't. If you can go right to it, that's great. And ideally, after you practice this a bit, you'll be able to do that. So just you decide what you need to do. Some students like to write it out all the time. That way it's easier to avoid mistakes, because sometimes if you're not writing it all, you kind of forget about terms. So you decide what works best in your brain. And as always, if you enjoyed this, please like, share, and subscribe so you can get more beautiful exponential and log content. Thank you so much for watching. I'll see you next time. Bye.